Hey guys, so today we're going to go over just a brief overview about regression and kind of what it means, what the point of it is, and I think you'll find that it's going to be a lot more familiar to you than you may think, because this deep into statistics at the very end of the second half of statistics, after doing hypothesis testing and z-statistics and test statistics and everything in between, it seems kind of funny it's going to divert back to something you're probably very familiar with from middle school or high school or whenever you learned this. So I think you'll be very comforted by how simple the concept behind regression is. So keep this in mind because it's very important as you start to get a little bit more nuanced into the depth of regression. So the overall formula for regression is just y hat equals b naught, they call it b naught, not 0, plus b1 times x. So that's probably going to look fairly familiar because it's a lot like what we knew in middle school or high school, which was just that old slope formula, the slope of a line. It's y equals mx plus b, where m was the slope of a line, the rise over the run, the change in y over the change in x, plus the y-intercept, right? It's the exact same thing, except it's just called, they just use different variables for it in statistics. So in this case, instead of m being the slope, it's going to be b1. So whatever you multiply by x is going to be your slope. So b1 is the slope, and that's going to be your rise over run is the way I learned it. And you might also know it as your change in y over your change in x. Oftentimes they'll give that to you, but either way, that's what that represents, is just b1 is the slope. B naught is going to be the y-intercept. So when you draw that regression line where it crosses the y-axis, that's going to be your y-intercept. And then x, so that x right there is going to be a value that just you plug in. So it's important to note that b naught and b1, those are going to be constant values that are going to stick in that formula. Once you find out what b naught and b1 is, those aren't going to change unless you change the nature of the entire regression line itself. However, x is something that you're going to plug in on your own based on what you're wondering about with y. So you plug in some x, it's going to give you an output y. So that's why it's called the predictor or the explanatory variable, because depending on what you put in is what's going to affect the outcome of the equation. Because see, the entire equation is y hat, that's what you're solving for, equals b naught, that's a constant number, plus b1, that's going to be a static number for this formula, times whatever it is you put in for x. So if you put in something for x, it's then multiplied by b1, that product is going to be added to b naught, that's going to give you y hat. So we're using an x, a predictor or an explanatory variable, to find what our predicted y might be. So a good example of that is going to be, let's say I wanted to find the relationship between someone's weight and height, okay? Which isn't going to be a perfect relationship, right? Because there are lots of people who are 6 feet tall and they're lanky and skinny as anything, and so they're not going to be, they'll be really tall, but not super duper heavy. And then there are other people who are pretty short, but they're pretty big as well. And so we should see some sort of trend between the two, but it's not going to be a perfect one-to-one relationship. So what goes on in a regression line is that we go and we do a sample. So I line up however many people I want to. Let's say we do 50 people, and I decide to take their height, and I get them to step on a scale, and I take their weight. And I go, okay, how tall are you? Okay, you're this tall. How much do you weigh? Cool. So I'm going to go, all right, you were this tall, and you weighed however much, and I'm going to plot that point, okay? And so every single point I'm about to draw here is going to be based on a sample that we actually went and took, and we're just plotting them on this scatter plot right here. So generally speaking, I would expect there to be a pretty positive relationship between weight and height, especially by the time you're, 2 feet tall, you're a little kid, you're not going to weigh 200 pounds, hopefully not. So we should see overall maybe a scatter, something like this, maybe not quite, but in general, it's going to be kind of a loose positive correlation relationship kind of trending upward like that, okay? So this is all based on actual data points that we took. So this regression line, it's also known as the line of best fit, okay? So I'm going to draw a line that best fits this scatter plot that'll kind of help us describe the relationship between x and y we see. So you can see that given these dots and given the general trend, that appears to be probably a good overview of what the relationship between x and y might be. So this right here is going to be the line of best fit. And the equation of that line, you guessed it, is y hat equals b naught plus b1 x. So your b naught, that's your y-intercept, that's going to be whatever this is right here. Your b1, your slope, is going to be you go up by some amount, you go over by some amount, your rise over your run. that's going to be your slope as well. So it's just your line of best fit. It's just generally explaining the trend between x and y. So the point of that is, this is going to be a totally not go along with the weight and height, but just to give you an example of how you solve for y hat given x, very simple. So let's say we are given that the regression equation, that the line of best fit is, let's say 5 is going to be your b naught plus 3 is going to be your b1 times x, okay? So I want to find out what my y hat is given some input x, right? So let's say my x is 1. So I'm literally just going to go, okay, equals 5 plus 3 times 1 is going to be 3. 3 plus 5 is going to equal 8. So what I would expect given this model, given this regression equation, is that if I had, in whatever units we're dealing with here, if I had an x of 1, I would have a y of 8. And it's important to note that that x and y pair is going to pop up on this line right here, because this is the equation of the line. So obviously if you plug into the equation, it's going to be on the line somewhere. One last thing we'll go over, and we'll go into more detail on this in a later video, is to keep in mind that there is error in these models oftentimes. It's not a perfect description of the relationship between x and y. Oftentimes there's going to be some variability, just like we were saying before. Someone who's really tall might be really skinny, and someone who's really short might be really big, and it's not going to be a perfect model. So anything I plug in to the equation is going to pop up on the line, but you see all those data points that are not on the line? Those are things that actually happened. Those are things that when we took our sample, we found an x and a y pair that fell somewhere on that scatter plot. So there's going to be an error, or a residual, some people call it, between the actual line of best fit and the points that you plot on there. So that's a pretty good overview of regression. We'll get into a couple of more nitty-gritty situations with different data we can run on it and different characteristics we might want to observe with it. But overall, if you can at least get the overall concept of what a regression equation is, it becomes much easier to frame the rest of it. So I hope that helped.